Okay, so here's number 25 of chapter 2. The driver of a car slams on the brakes when he sees a tree blocking the road. The car slows uniformly with an acceleration of negative 5.6 meters per second squared for 4.2 seconds, making straight skid marks 62.4 meters long ending at the tree. With what speed does the car then strike the tree?
Okay, so we have this car going to the tree, and it's going to crash into the tree. And what we want to know is the velocity right before the car hits the tree. So we want to know v final, and that's going to be in meters per second. What we are given in the problem is this value x, and that is 62.4 meters. We are given a, which is uniform, and it is negative 5.60 meters per second squared. We are given t, which is 4.20 seconds, and we are not given initial velocity. Remember, we're looking just for final velocity. Okay, so we have some kinematic equations that we can use. The first one is x equals 1 half at squared plus v initial t, but we don't know v initial here. However, we're not looking for v initial. What I would do is use the other kinematic, which is v final equals v initial plus at. Now we can solve this for v initial. So v initial is v final minus at. Plug that in here, and we get x equals 1 half at squared plus v final minus at times t, and we can solve this for v final. So x equals 1 half at squared plus v final t minus at squared. These combine, x equals v final t minus 1 half at squared, x plus 1 half at squared over t is our v final. So there we have our equation. We know what x is, we know what a is, and we know what t is. Now it's just plugging in numbers. So we have 62.4 meters plus 1 half times negative 5.60. I'm running out of space, so I'm not going to use units. And we have 4.20 squared divided by 4.20, and we can plug that into our calculators, and we will get 3.1 meters per second, because this is in meters and this is in seconds.